we consider a perfectly inelastic collision where two carts collide with one another. They're traveling in opposite directions, and then after the collision they stick together, and we want to determine how fast are they moving after the collision. So I have a 2 kilogram green cart, and it's traveling to the right with a speed of 8 meters per second, so it has a positive velocity of 8 because it's traveling to the right. It collides with a yellow cart that has a mass of 1 kilogram, and it's traveling to the left with a speed of 7 meters per second. Now the speed is 7, but the velocity of the yellow cart is actually -7 because it's traveling to the left, and we consider the positive direction to the right and the negative direction to the left. And velocity, of course, is a vector, and it has direction associated with it. After the collision, the two carts stick together, and we want to know what is the speed of that two-cart system after the collision. And after the collision, essentially they behave as one mass with a total mass of 2 plus 1, which is 3. Because there's no friction involved in this problem, we can assume that momentum is conserved so that the total momentum before the collision is equal to whatever the total momentum is after the collision. Now before the collision, the green cart and the yellow cart each have momentum, and we can determine their momentum before the collision, and that has to equal whatever the momentum of this whole system, the two carts together, is afterwards. Since momentum is mass times velocity, and we know the mass of the green cart, and we know the initial velocity, and the mass of the yellow cart and the initial velocity, we can determine their initial momentums. And if we know their initial momentum, that means we know their final momentum. Now, once we know the final momentum of the two-cart system and we know the mass, we can use the definition of momentum to figure out how fast they're going. So that's an overview of the problem, but then we can take it in steps and actually calculate the initial momentum of the green cart, the initial momentum of the yellow cart, and then move forward through that. So we start off by determining the initial momentum of the green cart. The initial momentum is just the mass times its velocity. So the mass is 2, its velocity is 8, so the initial momentum is 16. We can also determine the initial momentum of the yellow cart. Its mass, 1, times its velocity of -7. So that gives us an initial momentum of -7 kilograms meters per second. So the total initial momentum of the system is just the addition of the momentum of each one of these carts added together. So 16 plus a -7 gives you 9 kilograms meters per second. So the total momentum of this whole system before the collision is 9 kilograms meters per second. And since momentum is conserved, that has to equal the final momentum of the system. So the total final momentum is also 9 kilograms meters per second. Now we can use the fact that the total momentum is 9 to solve for the velocity, because we know these two carts stick together and have a momentum of 9. And momentum, of course, is just mass times velocity, and this is just the total mass of the system. So I have a final momentum of 9 kilograms meters per second, a total mass of 3, and that multiplied by the velocity is going to have to give me 9. If I divide both sides of this equation by 9, I get that the final velocity of this two-cart system after the collision must be 3 meters per second.